All right, so I'm going to teach you how to solve exponential equations like this today, and we're going to start with a much easier one like this. And I know you can just say, oh, it's 3 to the second, the answer's 2, and you're right. But what's the math way to solve it? You make the bases be the same. That's got a base of 3, that's got a base of 9, and they're not the same right now, but I could make it so they are the same. But be careful, because it's tempting to just go, oh, I could make this a 3, and then the bases are the same. But it used to be a 9. You can't just change a 9 into a 3. But you could change it into a 3 to the what? 3 to the what power? Say it if you know it. 3 to the second. All right, we're not trying to solve that original problem. That one's too hard. I was just showing you that's what our goal is. By the end of the hour, we'll solve that really hard one. But this one, I know you could have done it in your head, but now that you've got the bases the same, see, there's a math way to solve it. And that's if the bases are the same, then this has to equal this. Are you with me that I changed a 9 into a 3 squared? Do you get there the same thing? 9 and 3 squared are the same thing. You can do that. All right, so here's a much harder one. Everybody write this down. 4 to the 2x equals 8. Now, why is it much harder? Because you can't just change 8 into 4 squared, because that's not true. 4 squared isn't 8. So this is much harder, but we're going to do it the same way. We're going to make the bases the same. That implies there's some way to make it so that the left side's base and the right side's base are the same. This is the harder kind, where you don't just change one of the sides, you have to change both sides. I think if we change both sides to a 2, we could do it. I bet you this right side's going to be relatively easy for you. Would you agree that 2 is not equal to 8, but 2 to the what? 2 to the third, actually. 2 times 2 times 2. 2 to the third would be 8. So far, do you get what I did? I changed 8 into 2 to the third. Do you agree with that? Okay, then, can you get behind the idea that I want to change this 4 to a 2, but I can't just say 4 is 2. 4 is not 2, but it's 2 to the second, right? And now, what about the 2x? You have to bring it down. Now I challenge you, do you really think that that means 22x? No. What would happen with those powers? Multiply them. It means 2 times 2x. Now, copy this down. This is a good example problem. I was making both sides have the same base, and I knew that 2 would often work. And I'll give you this pro tip. When we do these problems, it almost always comes down to the base is 2 or the base is 3. Because if the base gets much bigger than that, if you go to a base of 4, you get that could have been a 2. You know what I mean? So 2 and 3 are the best bases that you can find. Okay, so now, great, Mr. Server, you got the same base. Now what? This equals this. They have to be equal. That will equal that. And if I can simplify it a little bit, 2 times 2x is 4x. Where'd the 2's go? I don't need them anymore. I just take the exponents, and they're equal. 4x equals 3? Yes, it does. And then I can just solve that. Is x alone yet? No. I just have to divide by 4. And x is 3/4. All right. Now, that means that back in this original problem here, this one right here, x was 3/4. Do you think it's likely you could have ever guessed and checked until you figured out that was 3/4? Probably not. So don't plan on doing this by guess and check. Sure, a couple of the early problems are that easy. You can just guess and check. All right. So what was the steps again? Recognize that those are not the same. Then go, how could I make them have the same base? A logical choice would have been think about making them both 4, but you realize 4 to the something doesn't equal 8. 4 to the first doesn't work. 4 to the second is too big, so okay. Then you realize 2 would be a good base, and you have to replace 8 with 2 to the third, and you replace the 4 with 2 to the second, and then don't forget to multiply when all the powers are like clustered together like that. All right, here's one for you to try. This won't be so bad. This will be kind of in between. Two to the 2x equals 1/2. Now, what did I suggest would probably be good bases? 2 or 3, and in this case, do you think 2 is probably a good go? Okay, try to make them both have a base of 2. You know enough about exponents to do this. I know it's a little tricky, but don't give up. It's got to be 2 to the something. This is already 2 to the 2x. This has to be 2 to the something. You learned it yesterday. 2 to the what? Is it 2 to the first? No. Is it 2 to the second? No. No, I guess I'm. How about 2 to the 0? No, that wouldn't work either. Do you get that it's 2 to the -1? And if you've forgotten that, I forgive you, but 2 to the -1 is 1/2. You'll have to be able to do that. That's coming on your test. You'll be expected to be able to handle that -1 power. -1, 2 to the -1 is 1/2. All right. And another kind of power that you're going to have to be able to handle is fraction powers. So I want to take a second and just talk about fraction powers. All right. 4 to the 1/2 power. All right, I know you haven't done fraction powers before, but you got to learn somewhere. And I'm your guy for this. I get to teach you this one. All right. That is the normal power, the 1. Anything to the 1 power just keeps the answer the same. So that part is really easy. You're going to put whatever your answer is to the power of 1. But you got to know what the fraction, the bottom part of the fraction is. And that is where the roots are. That is the 2 root of 4. What are you talking about? Did you know that when you write a 4 with the square root on it, that there's actually a little 2 there? That has, the whole time you've been calling it the square root, but it's actually the 2 root. We just call the 2 power squared, okay? And if I put a 3 here, that would be the cubed root. You could also say the 3rd root of 4. Okay, so that part right there is telling you what root to do to your 4. I'm supposed to do the 2 root of 4, also known as the square root of 4, which is 2. Cool. So what's the answer to the 4 to the 1/2 power? It's 2. It's technically 2 to the 1, but then that's equal to 2. All right, so that little fraction power, the thing on the bottom of the fraction, is what root you want. That brings up an important point. If I said, what's the 3rd root of 81, you'd have to be thinking, okay, what does 3rd root mean again? It means what times what times what equals 81. And actually, this one's almost impossible because it's a decimal. Never actually make you do that one. Okay, so let's do one that you would be expected to do. 3rd root of 27 comes up. What is the 3rd root of 27? 3. Because 3 times 3 times 3 makes 27. Okay. Another thing that's important, you can do cube roots of negatives. You know how square roots, we always be like, no, you can't do it because square root of -49 doesn't exist. But the 3rd root does. You can do cube roots of negatives. Why? Because think about it. If I made it negative, it would then just be what negative number times a negative number times a negative number will equal -27. And it would just be -3 times -3 times -3. So the answer is -3. So you can do cube roots of negatives. And now you know what a cube root even is. So what do you think that's called? Is it a square root? Is it a cube root? If you had to guess, what's the official way to say that? Quad root was a very good answer, and I would have accepted it, but there's a more common way to say it. Just fourth root. So whatever number's here, you just say that number, that root. So in this case, fourth root. If I put a 5 there, it'd be the fifth root. Sixth root, seventh root, eighth root, etc. Realistically, the highest we pretty much ever go is fifth root. That's the highest you'd ever probably have to do in this class. All right, so what's the fourth root of 16? It means what times what times what times what, like 4 times. And it's 2. 2 times 2 times 2 times 2 makes 16. So the answer is 2. So the fourth root of 16 is 2. All right, so now you understand what weird roots are. So if I said 16 to the 2x equals 2 to the first, have you already forgotten how to solve these? You want to make the bases the same, right? What did I say was probably a good base? 2, in this case 2, could be 3. So, can you do it? Solve. Make them have the same base. I'll work you up to the kind where you actually need those fraction exponents. This has already got a good base of 2. This one needs a good base of 2 also, but you can't just say 16 is 2. 16 is 2 to the what? Fourth is correct. And then don't forget the 2x. And do you really think that means 42x? No, you times those. So then you got 8x equals 1. And then you divide by 8, 1/8. Who had 1/8 before I said it? All right, cool, you're getting this. Let's do another one. 3 to the 2x equals 9. Now I've done enough of these now. Since you know that you just need the bases to be the same, you can do this. Have you got the problem copied yet? All right, next. Do it by making the bases the same. And then be prepared to talk to the kid next to you. And if they have a different answer than you, talk it through. Like maybe one of you's right and one of you's wrong if their answers are different. I've already seen multiple answers that people have for this. So be prepared to talk it through in case they have a different answer. Okay, let's compare them. What'd you get? All right, I'm changing that 9 to a 3 squared. Now my bases are the same. Then you have to go 2x has to equal 2. 2x equals 2. Divide by 2, divide by 2. X equals 1. There we go. All right, I think you're getting this. I don't want to go too fast, but you have to be able to handle problems like this, so let's do it. 2 to the 2x equals 1/2. Just 1/2. The first challenge is, well, it doesn't even have an exponent. Yes, it does. Second challenge is that you got to get the bases to be the same. That's going to require being good at exponents. If you can figure out what the exponent is to make them have the same base, it's going to be no big deal. All right, if the kid next to you got stuck, it's probably because they couldn't figure out, they probably are smart enough to know the base has to be 2, but they couldn't figure out how to make that 1/2 into a 2. 2 to the something. All right, talk to the kid next to you. All right. Josh, did you figure out how to make the 1/2 into a 2 to a power?
You do one half is 2 to the negative 1 power.
Perfect. That's it. And now they have the bases the same. That has to equal that now. 2x equals negative 1 divided by 2 divided by 2. X equals negative a half. Cool. All right. They're going to get more complicated. 2/3 to the 2 equals 4/9 to the x. Now be careful. 4/9 does not just reduce to 2/3. It's not a thing. If that's bothering you, it's like 2 times 2 over 3 times 3. Do you think that anything cancels there? No. So 4/9 does not reduce to 2/3. So it does equal 2/3 times 2/3 though, doesn't it? See what I just did there? I made the 4 into 2 times 2, and then the 9 into 3 times 3. So then it's kind of like 2/3 times 2/3, isn't it? Wouldn't that be making it the base of 2/3? Couldn't 2/3 be the base on both sides then? It could. I know only probably 2/3 of you have got this, so you'll have to probably help that kid next to you. 2/3 to the 2 equals, this could be 2/3. You just got to know how to do it. All right, solve it down. Make sure the bases are the same, and then you got your exponents are equal to the exponents. Talk to the kid next to you. You have nobody next to you. Check. Close. Oh, there you go. 2/3 to the 2. Nice. There you go. All right. So I totally see multiple people as I just walked for a second there that knew that it had to be 2/3, but you didn't know what to put. 2/3 to the second is equal to 4/9. See, these have to be equal. That's not something you do a lot, but you know it's true. If you're solving an equation, things that are right above each other have to be equal. And so 4/9 is 2/3 squared. Because see, the squared would happen to the 2 and the 3. Now, if I put a parenthesis around this, it'll make it even more official, like that. Okay? All right. Now, what haven't I copied down from the original problem? The x. There. So then, the base is the same. That equals that. X equals 1 then. How many of you got to x equals 1? Be honest. All right, that's most good. All right, if you didn't, you're going to maybe need to come up and ask me on a few of these. All right, the next one. 2 to the x plus 3 is equal to 8. Step 1, make the bases the same. That means you got to replace, this is the only thing that's really hard, is get the bases the same. From there, it's an equation to solve. It's easy. Can you make the bases the same? Can you change that 8 into a 2 to the what? Third. And then x plus 3 has to equal 3. That's weird. But you can solve it and just subtract 3. Sometimes when you get an answer of 0, people just freak out like, that can't be right. No, it works. Because look at the original problem. I'm going to go back to the original problem. 2 to the x plus 3 is equal to 8. And wouldn't it be okay to put an x is 0 in there, and then it'd be 2 to the third equals 8, and it works? Okay. All right. I think it's time to get to the worksheet. So this is the part where we have a digital worksheet. It's a Schoolage quiz. Always want to do your work on a little piece of digital paper, and I would ask that you all make a split screen so that I can see. You aren't going to just try to solve these in your head. It'll work for problem 1. But after that, please have a split screen going with your work on one side. Sure. Really prefer paper? I have paper, right? If you want scratch paper, there's a whole stack on my desk. Okay, got your split screen going? Would you read me that first problem, please? Nice and loud. Number 1.
5x equals 5 to the third power.
Nope, 5 to the x, you mean?
Yeah, 5 to that.
5 to the x equals 5 to the what? Just finish it.
5 to the third power.
Thank you. All right, so then, base is the same, right? That was the answer. 3. And see, in that problem like that, I get why you're like, why do I need to take out scratch paper? Because you can do that one in your head, I get it, but then it's very quickly going to become impossible. And if you try, you're just going to mess yourself up. So number 2 also probably could be done in your head. Mr. Breen, could you read me number 2?
10 to the 1 minus x equals 10 to the 4th.
So what I would want you to do on your scratch paper, I wouldn't copy the whole thing, but I'd copy that has to equal that on your digital scratch paper. And then from there, you just solve it. Subtract 1, and then how do you get rid of that negative? You can either multiply both sides by a negative or divide both sides by a negative. All right. I personally like multiplying by a negative. And then I get x equals -3. Cool. All right, now I want to do 1, 2, skip a few because I know that problem 9 is the first one that's kind of a beast. So please go to problem 9. Isaac, would you please read me number 9? It's a fraction.
1/2 to the power of x equals 4.
Excellent. So anytime there's fractions involved, people start to freak out a little bit. My advice to you is make them both have a base of 2. Remember me saying 2 is a good base? So make the 4 into a 2 to a power. That's easy. 2 to the second. Everybody can do that. But making the 1/2 into 2 to a power, less kids can do that, but you can do it. Can't just be 2 to the first. 2 to the second? No. How about 2 to the 0? No. How about 2 to the -1? Yes. And then don't forget to bring down the x. That means times. -1 times that x. And then you got the exponents, set them equal. All right? Okay, I'm not going to lie. Number 10, 11, 12, there's some tricky ones in there. And usually if you really get stuck, what you're forgetting is that if you want like 2/3 to equal 3/2, like this is not an actual problem. Let's say you had this one. Do you get that all you need to do is get one of these to flip over? What power do you put it to make it flip over? -1. Don't forget the -1 power flips things over. So if you got 2 fractions and they're like the same except you got to get them flipped, do you get that one of these has to be put to the -1 power? All right. So because they have to both be the same power. Could be 3/2 or 2/3. It doesn't matter. But if you're going to make this one flip over like that, you'd have to put a negative power on it. And then it'll be easy. Bases are the same. If there's no exponent, put a 1. All right, that is not one of your problems on the Schoology quiz, but there's one like it. Don't forget, when you have fractions you want to flip over, use a power of -1. All right, that's all I got for you for today.